Today we're going to look at a review of matrices and also add on extra information about multiplying two matrices together. To begin, let's talk about what a matrix is. It is a table or a type of spreadsheet, and it consists of columns and rows that have information, usually in the form of numbers, that allow us to organize a lot of our data. It can be described by its dimensions. The rows are the first numbers that come, followed by the number of columns. So for instance, if we had 3 rows and 2 columns in our matrix, it would be a 3 by 2. Each value in the matrix is called an element. We look at this matrix, matrix A. It has dimensions of 2 by 3, 2 rows, 3 columns. And each element is defined by what row and what column it is assigned. So for instance, in matrix A, element 2, 1 is found in the second row in the first column, which would be a 9. When we add or subtract matrices, the first thing we have to check is to see if it's even possible. In order to be possible, they have to have the exact same dimensions. When we find two matrices that have the exact same dimensions that we want to add, we take each element and add it or subtract it to the corresponding element of the other matrix. So as an example, I would take the first element, element 1, 1, in my first matrix and add it to the first element, or element 1, 1, in my second matrix. 5 plus 3 is 8, and you'll notice that in my final answer, that is the first element. Then I take my second element in my first row, so element 1, 2, which is a -1, and I add it to element 1, 2 of my second matrix, which is the 4, and that gives me a 3. So element 1, 2 of my final matrix is a 3. And then we go on to the second row. To subtract, you would obviously just subtract the two instead of adding them. Multiplying a matrix by a scalar or a simple quantity is fairly easy. We're going to take each element and multiply by our scalar amount. So to multiply a matrix by a scalar amount, we multiply each element by the constant or the scalar that's in front. So for instance, in this particular case, my scalar is a 5, so I take 5 times my first element. 5 times 3 is 15. Then I take my scalar of 5 and multiply by the second element. 5 times -8 is -40 that I have over here. And then go to a second row. 5 times 5 is 25, which is my final answer here. And then 5 times the 2, which gives me the 10. Now that brings us to multiplying two matrices together. This gets much more complicated than what we've done in the past. When you multiply two matrices, they do not have to have the same dimensions like we saw with addition and subtraction. However, the number of columns in the first matrix has to be the same as the number of rows in the second matrix. As an example here, my first matrix, if we call it matrix A, has 4 rows and 3 columns. It's a 4 by 3. The second matrix, matrix B, has 3 rows and 1 column. So it's a 3 by 1. Since the number of columns in my first matrix is equal to the number of rows in the second matrix, I can multiply them. And when I multiply them, I am going to have a 4 by 1 matrix as my answer. So I'll have the same number of rows as my first matrix and the number of columns in my second matrix. So let's do a little practice. Let's say I have a 4 by 3 and a 3 by 2 matrix that I'm multiplying together. First, I need to determine, can I multiply these two matrices together? I look at the second number, which represents the number of columns in my first matrix, and the first number, which represents the number of rows in my second matrix. They are the same. Therefore, I can multiply the two matrices together. What is the final answer, the result matrix, going to be? It is going to be a 4 by 2 matrix. What if we have an 8 by 2 multiplied by a 2 by 2? Well, since the number of columns in my first matrix equals the number of rows in my second, I can indeed multiply, and I'm going to have an 8 by 2 matrix as my answer. If we take a 5 by 4 and multiply by a 5 by 3, I cannot do this because the number of columns in my first matrix is not equal to the number of rows in my second matrix. So this one would not be possible. If I did a 6 by 3 by a 3 by 4, since the number of columns in my first matrix equals the number of rows in my second, I can multiply, and I'm going to have a 6 by 4 matrix as my answer. So now let's actually multiply two matrices together. Here we have a 4 by 3, and I'm multiplying by a 3 by 1. Since I have a 4 by 3 that I'm multiplying by a 3 by 1 matrix, since the number of columns in my first matrix equals the number of rows in my second matrix, I can multiply them, and I'm going to have a 4 by 1 matrix as my final answer. So I've set up a diagram here where I have a matrix as my final answer that has 4 rows and 1 column. My first member of my matrix is 1, 1. What that indicates is that I'm going to take the first row of my first matrix and multiply by the first column in my second matrix. That is going to give me 153 times 2, 12 times 3, and 82 times 1. Now eventually I'll add all those together. If I go with element 2, 1, that means I'm going to take the second row and multiply by the first column, which is the same as before. When I do that, I'm going to get 217 times 2, 6 times 3, and 146 times 1. Remember, 3, 1, I'm going to take the third row of my first matrix and multiply by the first column, which of my second matrix. So that's going to give me 197 times 2, 7 times 3, and 102 times 1. Now for element 4, 1, I'm going to take the fourth row and multiply by my first column. When I do that, I get 249 times 2, 8 times 3, and 158 times 1. Now I need to simplify all those by going ahead and doing the multiplication, and then adding all those together. I get a final matrix that looks like this: 424, 598, 517, 680. Notice that it is a 4 by 1 matrix. Let's do one that's a little bit more of a challenge. Here I have a matrix that is 4 by 3 being multiplied by another matrix that is 3 by 2. Well, since the number of columns in my first matrix equals the number of rows in my second, I can multiply them, and that is going to give me a final matrix that is 4 by 2. So to help us, I'm going to go ahead and draw a matrix that is 4 by 2, just putting boxes in to represent each of those elements. My first element, element 1, 1, that first piece tells me what row to use, so I need to use the first row. And then the second part of my element tells me what column to multiply by, so it's the first column. So 1, 1. When I do that multiplication, I get 1 times 5, 2 times 7, 8 times negative 4. Now for element 1, 2. This tells me I'm going to take the first row, but this time I'm going to multiply by the second column. 1 represents the row that I'm using, 2 represents the column that I'm using. Multiplying that out, I'm going to end up getting 1 times 2, 2 times 8, and 8 times 5. Now moving to the next row, this is row 2, column 1. So I take row 2, and I'm going to multiply by column 1. Doing that, I get 7 times 5, 6 times 7, and 4 times negative 4. Going with element 2, 2, I'm going to take the second row and multiply by the second column. That will leave me with 7 times 2, 6 times 8, and 4 times 5. Now for member 3, 1. Now I'm going to multiply my third row by my first column. So that's a negative 2 times 5, a 7 times 7, and a 10 times negative 4. Going with element now 3, 2, I'm going to take the third row and multiply by the second column. Doing that, I get negative 2 times 2, 7 times 8, and 10 times 5. For element 4, 1, I'm going to take the fourth row, multiply by the first column. And then for element 4, 2, I'm going to take the fourth row and multiply by the second column. Simplifying all those down, doing all the multiplication, and then combining all the numbers together, that's going to give me my final answer, which is a 4 by 2 matrix that looks like this: negative 13, 58, 61, 82, negative 1, 102, 108, 40. So when you look at the element numbers, the member numbers, the first number indicates what row you need to use. The second number represents what column you need to use. That is really the most difficult part about multiplying the two matrices. There's a lot of ways to make mistakes, but the basic process is you take the number of the row and multiply by the number of the column based on your member number.